Hi, my name is Randy Reed. I'm the Executive Director of the National Lighting Bureau. Today, I am moderating 5 panel discussions. This panel is titled 2020, the Year of Artificial Sunlight UV. Our panelists are Kevin Matthews from Signify, Jim Colantoni from Puro Lighting, and Robert Soler from Bios Lighting. Gentlemen, welcome.
Thank you.
Thanks for having us, Randy.
Thanks for having us.
Jim, the first question goes to you. In layman terms, tell us the difference between UVA, UVB, and UVC.
So in layman's terms, UVA really is the wavelength we probably see hit the Earth the most, right? So UVA and UVB both can hit the Earth's actually pass through the Earth's atmosphere, whereas most of UVC is going to reflect off that Earth's atmosphere and be absorbed by it. But UVA is what's really going to penetrate the layers of our skin, cause aging, cause skin damage. UVB is going to cause redness, skin cancer. It has lots of effects against us. UVC also has some negative effects, but that's where we see the most germicidal effects as well. So that's where we're going to see viral inactivation, bacterial killing. We're going to see the real damage and disinfection happen in the UVA zone.
Wait, the UVA or UVC?
UVC, I'm sorry.
Okay, so it's mainly UVC is what the focus is. And with UVC, can you explain to our audience some of the dangers of the technology?
Yeah, so depending on the specific wavelength of UVC, you've got the ability or the possibility of damage to both skin and really your corneas, right? So you get some major eye damage. Usually it's pretty painful. It's usually temporary depending on how much dosage you're actually getting. But it is a painful and temporary harm to those eyes and to your skin.
Okay, Kevin, can you speak to the specific wavelengths and which wavelengths do cause damage?
Well, specifically, I mean, you want to be very cautious with anything within that C band. The higher wavelengths of C bands, such as the 254, you have to definitely be cautious with that. You don't want to have any direct exposure to 254 nanometer wavelength. There are some newer studies in regards to the 222 nanometer wavelength from UVC that some of those newer studies are showing some safety to have direct exposure with regards to skin and eyes. But generally speaking, I would say anytime you're dealing with the UVC band, you really need to take some caution and be careful with designing the space, make sure that the fixtures you're using are well designed. A lot of care needs to be taken with anything in 222. I'm sorry, with regards to anything UVC.
Okay, let's talk about some applications. Where would you use 254 nanometer UVC? 254
is a great option, and that's the longest. It's the wavelength that's been used the longest within the industry. So 254 is a great option for direct UVC disinfection, meaning either on fixtures aimed straight down within a space or potentially on the mobile carts and things of that nature that you've seen. In that application, you cannot have any humans or animals directly occupying the space. The other great application for 254 nanometer would be for upper air disinfection. So the great thing about upper air UVC disinfection is that you can occupy the space safely because we are targeting that air above people's heads. And here again, you have to design the space properly and carefully, but you can occupy a space safely when you're doing an upper air disinfection model. And then the third area that I'm seeing a lot of application for would be what we would refer to as chambers. So reach-in boxes where I would say that's probably the safest method of everything because that UVC light source is completely contained within that box. If you open up the box or the chamber, there are safety protocols that turns it off. So it completely eliminates any risk for direct exposure to people using the machine.
Okay, and we see a lot of those chambers all over the place. And, you know, some of them we're familiar with the brand names and then others we are not. Robert, what's your opinion of some of these chambers out there?
Yeah, I think that the chamber approach is certainly useful. I don't know that, if it's these are things that you might put your phone or things in. And I don't know that I see all the value in, my phone that I've always been touching, kind of getting disinfected. I do think one of the applications that I think is really important is kind of some sort of air purification system, having that UVC so instead of having the upper room cavity, as you're bringing in air to be able to clean that in a way that there is no direct human exposure. I think some inner room air purifiers also make a lot of sense. But I think the content box is not something I don't know I see the value in doing it personally.
Okay. Gentlemen, let's take a typical office application. And the office has been closed because of COVID. And now the people are beginning to come back. They have the option to come back. And what kind of application certification should be done on these offices that have installed UV in the HVAC, upper air room, and the 254 when people aren't present? What sort of certification should be done to ensure that the job has been installed correctly and no one's going to be harmed?
I would say for any occupied space, when you're talking luminaire based,
Right.
UL 1598 is a newer standard. And for anything that's luminaire based, that's a great standard that I know we're totally embracing that because it really does a great job looking at all the safety measures that need to be taken into place. It gives some guidance, but it talks about the PPE required for the maintenance personnel. Does a great job with talking about the installation and the care needed on the installer side and the maintenance side. But what I think is probably more critical is that it's also tying in IEC 62471, which is basically a photobiological assessment, which helps mitigate risk against damage of UVC towards eye, skin, and lungs. So any occupied space or a space that's going to be occupied and UVC is also being used, I think that UL 1598 is a great tool that the industry should be embracing for any fixtures.
Okay. And again, you said UL 1598. I mean, that standard's been around for 20 years. Are you telling me it's been updated now to include?
It has been updated. The update first hit roughly 2 months ago, maybe a little longer. But the reason for that is UL stepped in because there's a little bit of an issue on the commercial side, but on the consumer side, it is rampant Wild West. And we're seeing all sorts of companies that are trying to integrate UVC products that have never done anything with UVC. They don't know the safety measures that are needed. And they're just throwing product into the market. A lot of times it's not even doing anything. A lot of times it's flashing blue LEDs that are not even UVC. And people are buying into this.
So Jim, do you think it's rampant Wild West just in the consumer area, or is it rampant Wild West in the commercial area?
I don't think it's as rampant in the commercial area, but completely agree with Kevin. We need more regulation, right? So we need the EPA, we need FDA, we need OSHA, we need people to step in here and say, these things should be done this way. Right now, the best resources in terms of testing devices is other companies testing their competitors' devices or just random devices on the internet. There's a company out of New Jersey that's literally posting videos every single day of UV wands and things like that. And they're not doing anything. Literally, there's nothing coming out of those UV wands.
Robert, what's your opinion of testing the app at the application level to make sure that the UV, if you have too much UV, you're harming people. If you don't have enough UV, you're creating harm. And if you have the wrong type of UV, you're creating harm. So whose job is it to ensure that the dose at the job is absolutely perfect?
Yeah, there has to be somebody that comes in and regulates this. I completely agree with what everyone here is saying is, there's different kinds of UV. Everyone treats UV as the same thing, but they're very different and they're very different use cases. And as you say, the dosing is really important. And I think that people don't understand it. And if we don't get regulations, people are going to get bad results. They're going to have irritated eyes, and now they're going to blame all UV, and all UV is going to be bad. So I think it's really important that somebody steps in and tries to regulate this from a use case standpoint for sure.
Yeah, and let's expand on that, because I agree that somebody needs to do that. Should that be the government, or is our industry capable of doing this ourselves?
That's, you know what? I would defer to Jim and Kevin on this one, because they're in it a lot harder than I am. I'm more of a biologist trying to speak on the biology standpoint, but regulation is certainly key, and I don't know if there's any efforts ongoing to try to push this forward.
All right, Jim, Kevin.
So my opinion is the IUVA is trying to go to different regulators and really start this conversation and push it. But I'll tell you, especially from the medical industry, I don't know if they're so overwhelmed right now. You're not getting any feedback from those medical industry regulators right now. I know the EPA is actively talking to companies about their claims. So there's at least that starting to happen. I think they were buried at the beginning, but we have companies out there right now saying, well, UVC is proven to kill COVID-19. So we're just going to put it all over our spec sheets. It's going to be all over our website that we and our products inactivate SARS-CoV-2. You can't say that. Right now, you can't legally say that unless your device actually has been tested. So there's a lot of claims out there. And I just don't think, I don't think the industry can do it by itself, because I think there's too many people in the industry. It's like the early days of LED, right? We need I hate to say it, but we need almost like a DLC type of consortium to actually help to regulate this. And Kevin, I'd lean on you too, right? You guys are one of the biggest players in the world, right? So I feel like your team hopefully is helping to push this along.
Absolutely. And to Jim's point, I'm seeing all sorts of companies that say, well, Signify's 254 nanometer lamps have been tested and proved in a scientific study to be effective with deactivating SARS-CoV-2. And that's very true. But the benefit going back to the UL 1598 is the whole fixture, including lamp, is what's being tested. You have to test for what's coming out of the fixture. You can't just take a bare lamp and say, well, that's going to work in my fixture, and that UL 1598 is going to translate over. And then if you take it a step further and look at a direct UVC application, that also requires to have a series of controls to make sure that the space is not being occupied when those fixtures are turned on. So in that case, the entire system, including controls, is what's getting that UL 1598 stamp, not just the luminaires. So I've had questions of, well, can I use your luminaires and someone else's controls? And the answer is no. You have to have a completely UL approved system if you're going to look at a direct 254 nanometer application.
Okay, now, Kevin, let's expand on that, because if I'm correct, Signify sells their UV products through certified, trained distributors. Is that fair?
Correct.
Okay.
Well, that's the way it used to be for UVC lamps. Right now, the UVC lamps are only sold through the OEM channel, and that's because of the huge global demand right now for the 254 UVC lamps.
Okay, I understand that. So I think we can agree with 254 used in HVAC next to the coil, really no issue there. In the upper air, as long as they're mounted 7 feet, there's really no issue, I guess, unless there's a reflectance. The issue is when you're mounting 254 in unoccupied spaces and you're using it. So you mentioned controls. How would those controls work?
Well, you'd have to have a safety siren and or alarm. You'd have to have door contacts, door lockouts. If someone bypasses the door lockout, you have to have the contact that will deactivate the system.
So wait, you got to back up for me. When you say a door lockout, so the door is connected to a system.
Correct.
The door opens, it turns off.
Correct.
Okay.
That's the
Keep
way a properly operating system should be working. Yes.
Okay, and is that on a timer? What if somebody, if stays in the room and falls asleep at their desk?
You also have to have sensors within the space, and I'm not talking a standard occupancy sensor. We're basically doing thermal mapping to make sure that there's no presence of animals or humans occupying those spaces if that system gets turned on.
You've got them at the door, and you've got them in the room.
Right. So you would very easily have it on a timer system. So if you're talking about normal business operations, the ideal scenario is after hours. But I've seen a lot of public spaces being designed where you have the restrooms deploying a direct UVC disinfection model just for restrooms only. And restrooms are something where you can easily lock it out for 10-minute periods throughout the day.
Okay, I get it. So yeah, this restroom is being cleaned. Go find another one.
Right.
Okay. What about 405 nanometers? Does that do anything?
For germicidal, it is. Jim, go ahead, speak up if you want to.
I was going to say, from a bactericidal effect, right? It does have some antimicrobial properties, right? But they take a long time, and you're not going to do anything to a viral pathogen whatsoever. So there's been no proof to any type of viral pathogens.
Okay.
So it's an interesting technology, but I think through the pandemic, it's lost a little bit of its luster.
Okay. So 254 is the magic number, and for restrooms as well, because I'd heard of people putting 405 into a restroom, but that's not going to really do any good.
I think really the UVC band in general is what's vitally important, right? That 265 number is actually the most potent. And then actually that far UVC zone is actually the most virucidal, right? So it's going to have the most effect against viruses specifically.
Okay. So that's a great point. And Jim, I'm not aware of any 265 nanometer product on the market. Is there any?
Yeah, so the most UVC LEDs are going to fall between that 265 and 280 nanometer range. Now we're a ways out from true efficiency that actually can make sense in that zone, but there are products that are coming and products that I think will make their way into the market over the next year or two that make sense in that zone.
Okay. So Robert, we're in late 2020. In 2030, what will an office look like as far as lighting disinfecting?
Will we be on the moon in 2030, first of all? I mean, I'm sorry, on the moon or Mars, one or the other?
Now, will we even be in offices? I don't know. But if we are in offices in 2030, what will it look like?
Yeah, you know what? I'm actually one of the naysayers on this as kind of a long-term standpoint. I kind of have a position, and I came. Jim kind of alluded to it with his comments. I came from NASA's Space Life Science Lab, where we tested a bunch of stuff on how life lives on Mars in a Mars spectrum, which doesn't have the ozone layer. And it turns out life can't be sustained when you have a full UVC environment. So I do think that there are benefits to having it in certain regions, but if there are people talking about continuous disinfection and having 222 just everywhere all the time, I think that those things are not. I would strongly urge that that's not the way that we go. And if there are proper lockouts and proper ways to do it using things that are known to work, disinfecting air, but just disinfecting everything all the time is probably not a way that I would recommend going. And I do think that, disinfection part-time has long lives and long longevity. But I don't think that it's going to go to the world where some people are hoping, where it's just UVC in all spaces at all times. And I hope that with
LED, right? This is what we've seen with LED. LED now is everywhere. I would not have thought that in 2003, 2004. And so the question is, will UV be everywhere? Okay, Jim, what's your opinion of that? Will we see UV everywhere long term?
No, so everywhere is a loose term, right? I think too loose of a term. Should it be in my office right now where I sit inside of my house? Absolutely not. I see almost no reason for that whatsoever. Should it be in an operating room, and should it be in the luminaires inside of an operating room? Yes, I think it should be. Now, should it be operating 24/7? Probably not, right? It should be operating on some sort of schedule when it's safe to do it, assuming that maybe it's 222 and maybe 222 has been more proven to be safe, or maybe it's traditional UVC, right? And it's something that we can use on a schedule throughout the day. But I agree with Robert. And Robert and I had this discussion on LinkedIn, right? Where I do think the one thing that the alternative is more chemicals. And I have a problem with just constantly pushing more chemicals into the space. I like this idea of non-chemical disinfection if it can be done in a safe way. That's really the thing that I think is most important here.
Kevin?
I think it's going to be part of our lives for a long time. Coronavirus has affected each and every one of us. It's affected almost every business out there. Even if there are vaccines that prove to be effective next year, I think what we've all lived through this year is going to be in our minds for a long time. So 10 years from now, I think it's very likely that you'll still see UVC fixtures, maybe not widespread, but in key focus areas. I see it's very probable to see them in a commercial space. If we continue on for 20 years without any issues from coronavirus and nothing else new popping up, I think it'll probably kind of go back to the way things were and start to die down some. But I think for the short 5 to 10 years period, I think it's going to be part of our lives.
Okay. Gentlemen, I've tried to cover everything on the list that Ruby put together. Are there any other subjects we haven't covered that you feel strongly about that you would like for me to ask the panel?
I think there's some value in the upside of UV. I tend to disagree with Jim that UVB and A is bad for skin. There's some carcinogens, but UVB is where we get vitamin D production, and vitamin D deficiency is huge because we spend all our time indoors. And there's some new science coming out that stuff in the near UVA is really useful for energy metabolism, some things in development that are important. So I think that I don't think UV is just about blanket disinfection. There are some benefits that we as people need in the UV space in the A and B range.
So I've actually have read some of that, Robert, and I agree with you. I think our challenge has been we just have always banded it, right? So it's all of UVA is bad. All of UVB is bad. Whereas there are certain wavelengths, and I think you guys at BIOS have proven that, right, in certain wavelengths for blue light specifically. The benefits there, I think there are some benefits as we can get more precise with what we're producing. I think there's some huge benefits out there. And I have the vitamin D deficiency is one that I've read over and over again recently.
Yep.
Okay, very good. Kevin, closing comment?
Closing comment, I think there's a lot of value to use UVC as a tool. It can't be looked at as a cure-all for everything. We need to look at it as a layer of protection. So can you completely stop using chemical disinfectants? No. Can you completely stop social distancing right now and maybe face masks? At this stage in our life, I think it's very prudent to continue on with those things. UVC is just an added benefit to another layer of protection.
Okay, very good. Jim, any closing comments?
No, I just think, we're in a really interesting time for the lighting industry where, again, we've had sort of this leadership in the LED space, which has sort of connected us to IoT, right? Connected us to, other technologies over the past 10 years. This has been interesting where we have a chance to lead again. Can we lead in a strong way and do it safely across the board?
Good point. Robert?
Yeah, I would just say if anything, this teaches us and brings to light the the power of light, the ability for it to do so much, and in when it's used in a proper way, how it could be used for such benefit. I think this UVC is one way to kind of promote that there's all these other wavelengths that are actually really important to life. And that would be my closing comment.
Very good. Thank you all.